Question number 18. The diagram shows a vertical cross-section ABCD of a surface. The part AB and CD are straight and have lengths 2.5 and 5.2 meters respectively. AD is horizontal and AB is inclined at 60 degrees to the horizontal. Points B and C are at the same height above AD. The parts of the surface containing AB and BC are smooth. A particle P is given the velocity of 8 meters per second at A in the direction of AB, and it subsequently reaches D. The particle does not lose contact with surface during this motion. Find the speed of P at B. Okay, so we need the speed here. So let's look at this surface. Okay, so we know that U is 0 at A, and because it starts from rest, and we know we need to find the value of V, we have the distance S, and we need the acceleration. Once we have that, we can use equations of motion and get the value of uh, speed at B. Okay, equations of motion can only work on surface AB and surface CB because they are straight line. Also, the acceleration is constant throughout. Okay. So, uh, how do we find acceleration? We're going to apply Newton's second law on the journey AB. Excuse me. Okay. So, it's a particle. There's no forward force mentioned. There's going to be a backward force, which is the gravitational pull. So, mg sine theta is going to be that component. So, forward force is 0 minus backward force is m. What is the mass? We don't know. Times g is 10 times sine 60 equals to ma. Forward force minus backward force is equals to ma. M and m gets cancelled, and you can find the value of a, which comes out to be minus 5 under root 3. Now we have the acceleration, the distance, the u. We're going to use v square equals u square plus 2as. That gives us the value of v. 0 square plus 2 times minus 5 under root 3 times s, which is 2.5, which gives us, oh, I've made a mistake. The initial speed is 8, not 10. Sorry, not 0. That's a big mistake. This is 8. Okay, so this would be 8. Okay, which gives us v equals 4.55. Okay, so we know the speed here is 4.55. And also the acceleration here is minus 5 under root 3. All right, show that the maximum height of the cross section above AD is less than 3.2. Okay, before we start part 2, one could have also been done using the energy conservation method, which is work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. There's no driving force, there's no resisting force from A to B either. So it's just loss in energy is equals to gain in energy. This is energy. Okay. And the loss in energy is going to be the kinetic energy loss, and the gain in energy is going to be the uh, potential energy gain. So we're going to write mgh here, mg, and h is this length, which is 2.5 sine 60. And for loss of energy, we're going to write half times m times bigger speed, which is 8 squared, minus smaller speed, which would be u squared or v squared. Let's write v. M and M can cancel, and you should get the same value of V, which is 4.55 meters per second. Okay. Part 2. Show that the maximum height of the cross section above AD is less than 3.2. Okay, let's see. Show that the maximum height of cross section above AD, this, so this is less than 3.2. This is what we have to show. Okay, how can we show that? Okay, if we stretch this line, take it till here. Okay, and this angle is 60. Then if we consider it to be a straight line motion, which it is actually not, but we're considering it, so this would be the at the highest spot speed is 0, and here the speed is 8, and the acceleration is going to stay the same as part 1, which came out to be minus 5 under root 3, because forward force minus backward force is equals to ma would stay the same. Okay, so A is known, U is known, V is known. Use these three to find S using V square equals U square plus 2AS. This is 0. Find S from here, and you should get you will get 3.6950. Okay. Now that is going to be this length. Now let's find this length. This would be the distance times sine 60. So height would be 3.6950 times sine 60, which comes out to be 3.2. But if the blue length is 3.2, then the actual height, which is from here to here, has to be less than 3.2. So since B to top is curved, H max is going to be less than 32, sorry, 3.2. 3.2 meters, because we had assumed a straight line, and if this graph was a straight line graph, then we would get 3.2 as the maximum perpendicular height. So the actual perpendicular height needs to be less than 3.2. Again, you can use the conservation of energy equation here to find H and then show that it's less than 3.2. Okay, part 3. State briefly why P speed at C is the same as B. Okay, so they're asking why are the speeds same at these 2 points. That's because there is no friction from B to C, and also the heights of B and C are the same. So two reasons, same heights, so same potential energy, and no friction. That's why. Okay. Part 4. The frictional force acting on the particle as it travels from C to D is 1.4 Newton. Given that the mass of P is 0.4 kg, find the speed with which P reaches D. Okay. Again, you have two options. You can use equations of motion because it's a straight line, or you can use the work energy principle. Okay. Let's use both. I'm first using equation of motion. So I need acceleration. This would be mg sine theta. This would be friction, which is 1.4. And this distance is 5.2. Okay. Let's use forward force minus backward force is equals to ma. The forward force is mg sine theta. Okay, now the problem is we don't have this angle theta. So we will need to find it somehow first. Okay, so this length from here to here is going to be the same as this length. Okay, and that's this is 2.5 sine 60. So this will also be 2.5 sine 60. Whatever that value is. Okay, so now I'm doing sine theta equals opposite over hypotenuse. Okay, so this should be the value of sine theta. Let's see what do we get. 5.2, not 5.5. I'm getting 0.416358. Now let's use forward minus backward is equals to MA. So mg sine theta. Instead of that, I'm writing what I just got, 0.416358. Minus backward force is 1.4 is equals to MA. Okay. The mass of the particle is 0.4. Let's use that. This would be 0.4. This would also be 0.4. Substitute that and get the value of A, which would come out to be 0.6635. Meters per second square. Okay. Now we need to find the speed with which P reaches D. So now we have A. We have the U at C is the same as U at B, which was 4.55, I believe. Yes. Preferably use the unrounded answer. Okay. Then we have the S, which is 5.2. Okay. And we will find V using V square equals U square plus 2AS. So square root U square plus 2AS. And when you substitute all these values, you should get 5.25. Yeah, right. This is how part 4 is done using equations of motion and Newton's second law. Okay. You can also do part 4 using work energy principle, which is again work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Okay, no driving force here. loss in energy will be considered. Work done by resisting force would be considered because now force of resistance is given, which is 1.4, and it covers the distance of 5.2. So work done by resisting force would now be this, and then gain in energy has to be considered. Okay. Loss in energy is the potential energy loss because from C to D, height is decreasing. So we'll do mgh. So m is 0.4, g is 10, and height was the same like discussed before. The height is still 2.5 sine 60 from here. Okay, so instead of 8, I'm writing 2.5 sine 60. Okay, on the other side, we need the gain in kinetic energy. Okay, that's going to be half times m, which is now 0.4, times bigger speed square minus smaller speed squared. So we're going to do v squared minus the initial speed was 4.55. You solve this and you should get the value 5.25.